In this video, I'm going to talk about mole-mole stoichiometry problems. The mole-mole, the first mole indicates what you are given in the problem, and the second mole is indicating what you are asked for at the end, what you're supposed to find. So we're going to be given moles of one thing and asked for moles of something else. In order to solve any kind of stoichiometry problem, you need to have a balanced equation. So we have a balanced equation here to work with. I like this one because it has all different coefficients. A 2 in front of aluminum hydroxide, nothing, which means a 1 in front of aluminum oxide, and a 3 in front of our water. That way it's easier to see where our numbers come from in our problem. Here's our problem that we're going to solve. How many moles of water will be formed by the decomposition of 12.4 moles of aluminum hydroxide? Decomposition just means you have one reactant which is coming apart into two or more products. You always start with what you're given. In this case, we are given 12.4 moles of aluminum hydroxide. So we're going to start with that. Now keep your labels on here because that helps you solve the problem correctly. So here's our given. We can think of that as being over 1. So we need a conversion factor here to change from moles of aluminum hydroxide to moles of what we're asked for, which is water. Since we have aluminum hydroxide on the top, we need to have moles of aluminum hydroxide on the bottom here so that our units will cancel. And we're trying to find moles of water, H2O. Now in front of these, whenever you have mole over mole and two different substances, this is called the mole ratio. And you have a mole ratio in every single stoichiometry problem. Where you get the numbers that go in front is from the balanced equation. That's why you need a balanced equation in order to solve these. So in front of water, we need to go up to our balanced equation, find water, and the number, the coefficient in front, 3, is what I'm going to put in front of my water here. So this 3 comes down here into the equation. And then we go to our aluminum hydroxide, which was at the beginning. Its coefficient is 2, so I'm going to put a 2 in front of it in this. And that is it. You just balance your equation and then take your given, multiply it by your mole ratio. Whatever you're given is going to go on the bottom so that these units cancel and you're just left with whatever's on top. So we are going to take 12.4 times 3 divided by 2. And we get 18.6 moles of H2O as our final answer. Notice there are 3 digits in our given number, and there are 3 digits in our answer, so our significant figures are correct if your teacher requires those of you. Here is a second problem. We have a new equation at the top, balanced already. Always check that, and it is balanced. And our question is, how many moles of SF4 are needed to react with 25 moles of water? Notice this time they're both on the reactant side. That's the beauty of these problems. It doesn't matter what side they're on. You could be given a reactant and ask for a product. You could be given a product and ask for a reactant. You could be given a product and ask for the other product, or given a reactant and ask for the other reactant. Any which way, it works exactly the same. If you'd like to pause the video here and try to work it out, and then hit play to check your answer, that might be a good plan. We are going to start with what we're given, and we're given 25 moles of water. So this is going to be our given, 25 moles of water, which is H2O. Now we need a conversion factor to get it from water to SF4 that we're asked for. Since water was given it's on the top here, we need to have moles of water on the bottom so that our units will cancel. And on top will be moles of what we're trying to find, in this case SF4. We go to our equation to find our numbers that go in front of mole. So SF4, if we go here, there's nothing. Well, nothing means a 1. So we're going to put a 1 in front of our moles of SF4. And then in front of water, we have a 3. So we have a 3 here in front of our water. So for every 1 mole of SF4, it requires 3 moles of water to react with it. That's what our mole ratio tells us. Now, we have moles of water and moles of water. Those units cancel. So we are going to take 25 times 1 divided by 3, and our only unit left is moles of SF4. So 25 divided by 3 is equal to 8.333, repeating on and on and on. So doing significant figures, we go back to our original problem. Don't ever use the conversion factor. Go back to the original problem. We have 2 digits, so we're going to keep 2 digits. So our answer is going to be 8.3 moles of SF4. Keeping the units on will really help you figure out which one needs to be on the bottom and which one needs to be on top. It's common to try to take a shortcut and leave those units off, but then it's really easy to make a mistake and flip your mole ratio upside down, and then you get the completely wrong answer. I hope this has helped, and come back for more if you need help with other types of problems. Leave me a comment if there's a specific kind of problem that you would like to see. Please like and subscribe. Have a great day.